Hey guys, so here is our first lesson of our calculus chapter. So this is calculus chapter 1, and we're starting off in section 1.2. Don't forget you can get all the downloads from right here on the website. So if you go under calculus chapter 1, you'll have one document for the outline of the notes that I'm going through on these videos. So I would encourage you to print these. These will be really helpful for you to just fill out the notes as I go through with the video, and that'll make life a lot easier for you. The textbook, you're not going to want to print that. It's pretty lengthy, so I would just say for this one, just go ahead and download that, pull it up on your computer or phone, and you can always just do the book work from there. So those are going to be here for you. There are solutions to all of the homework problems in here for you, like worked out solutions. So this will be a great tool, especially since we're not going to be together very much going over these things in person. So take advantage of that so you can help get some of your own questions answered as you're doing that. So here we go. We're just going to jump into our first lesson here. So let me widen that out a little. Let me zoom out here. I'm moving a little tight. That's all the way out. All right. So first chapter we are getting into is on limits, and so this will start in the chapter 1 of the book, starting on page 65. You're going to want to look at that for some of the notation of what a limit looks like. I'm going to have a few things written in my notes here, but let me just show you. This is page 65 of the book. And so here is the general notation for a limit. So we would read this as the limit as x approaches c of f of x, so that's our function, whatever the main function is the limit. So they use capital L to represent the limit on these. So here's one with some real numbers thrown in. So if you look at this guy, so we're saying the limit as x approaches 1 of the function of f of x is 3. So they're telling us that 3 is the limit. And so this is kind of the sort of the full-blown notation that you would see right there. So you can see by this table, and I'm going to show you with a table and with a graph, because we're going to get comfortable looking at both of these. Let me refocus real quick and see if this makes it a little more clear. So some of this is coming in a little light, but if you have, this is just from the textbook, but you can either have the textbook pulled up in front of you like I do, and the notes as well, and so hopefully that'll help any of this that isn't as clear. But so they're saying the limit of the function, right? So this graph represents the function that we're taking a look at. It's this guy right there. So this is what f of x equals. This is our function that we're seeing right there. And so the limit as, there's a better view. So the limit as x approaches 1 of the function. So if you look, here's from the table. So as my x's get closer and closer to 1 from the left, right, you'll notice I'm getting closer and closer to a value of 1. Well, look at what's happening to the function or the y values as my x approaches 1. Here's the y values. You can see that they are getting closer and closer and closer to a value of 3, right, as I approach 1 from the left. What if we approach 1 from the right? So now I'm kind of going from bigger to smaller. So my numbers are getting closer and closer and closer to 1. So we are approaching 1 from the right. And look what is happening to the function or the y values as we approach 1 from the right. So you can see that these guys get closer and closer to a value of 3, right, as we approach 1 from the right. So as I approach 1 from the right, I'm getting closer to a value of 3. As I approach 1 from the left, I'm also getting a value of 3, so that means the limit as my x approaches 1 is 3, right? That would be our value, our limit. So that's what this means right here. So this is the way by doing it, by just looking at a table of values. So we can always plug in numbers, look at a table of values, and see it that way. A graph is a great way to look at limits. It's a real clear picture of what our limit would be. So if you just follow on the graph, so as my x values get closer and closer to a value of 1, so as I move to the right, you can see that my y values are approaching 3. You can also see if I were to approach 1 from the right, so as I move to the left now, on my x-axis, my y values are also getting closer and closer to a value of 3. So you can see that the limit from both ends is approaching a y value of 3 right here. So why could we not just plug in our value for 1 in for x, right? Well, you can see if I were to plug in 1 for x, I would have 1 minus 1 on bottom, and that would give me a 0 in my denominator, and so that would be undefined where it's 1. And you can see by the graph that we also had a hole in the graph right there at 1. So this is an undefined point. So when we get the limit, we're simply stating what the graph is approaching, not its actual value, because this doesn't have an actual value. So this is just the limit or the value that we are approaching from the right and from the left. So that's what it's going to look like from the graph. So let me go through a couple of these. So I've scribbled out some of my writing on here because we're going to see this in the book. And so I started doing this by hand, but then I saw it in the book, and so I'll just show it to you from the book. That'll be a little bit easier since you guys all have access to that. Give you a little less writing to do. So here's our new function. All right, so this is f of x right here. So we're trying to find the limit as x approaches 0 of this function. This is our f of x. So again, why can I not do direct substitution? So if I were to just simply try to plug in 0 for x, I would have a 0 on top, and that would be fine. But if I put a 0 right there, 0 plus 1 is 1, the square root of 1 is 1, minus 1 would give me a 0 in my denominator, so I cannot use direct substitution. So, and that's what I was trying to say with this statement right here. I can't use direct substitution since the limit as x approaches 0 of f of x does not equal f of 0. I can't sub in 0 and get my solution. All right, these two things need to be equal to each other in order for that to exist. So again, let me show you the two ways that you can do this, whether by table or by graph, just like we did up above. So this is on page 66 of your textbook. I'm going to show you with the table first. This actually starts at the bottom of page 65. This is a good view of it. Actually, I'm going to show you from this view. Get the calculator table. So this is when you could actually see this table in your calculator if you wanted to. If you just graph the function, so again, here was the original function. If you graph this function in your calculator and then go to the table, this is what you would see. So first things first, you can see when x is 0, it's undefined, and that's why it says error. And we already showed why that is the case. But we're going to take a real close look at what's happening to our x's as we approach 0. So you can see in this case, I am approaching 0 from the left, from the negative, but my values are getting closer and closer to 0. So what is happening to our y values as our x approaches 0? Our y values approach a value of 2. All right, you can see these guys are getting closer and closer and closer to a value of 2 from the left. If I did it from the right side, so from the positive, so as my x's approach 0 from the right, from the positive side, what is our y value approaching? So you can see our y value is also approaching a value of 2. It gets closer and closer and closer to 2. It can't actually be 2 because again there's a hole in the graph. It's undefined at that point. So either a hole or an asymptote is going to give you that undefined value, which is what we're getting on this. So from the left we are approaching 2. From the right we're approaching 2, which means our limit. And I don't see it written on here, so we'll write it this way. So we would say the limit as x approaches 0 of, and I'm just going to put f of x instead of putting in the whole function because it was kind of lengthy, is 2. So 2 is going to be our limit, right? That's the value that we are approaching from the right and from the left. If you were to graph this in your calculator, here's what it would look like. And so again, as you see right here, there's a hole in that graph. So as I move from left to right, so from the left, as my x's get closer and closer to 0, my y values get closer and closer and closer to 2. All right, so this is 1 right here, this is 2. Also, as I approach 0 from the right, so as I go this direction, you can see that my y values also approach a value of 2. So as long as we're approaching the same value from the left and from the right, then that would be our limit for the graph. We are going to run into ones where you can simply approach a value from either the left or the right. And so I got some of that notation to show you on my note page as well, if I can find it. And so that's what I had right here at the top of the page. So if you see a little negative, that means you are approaching a value from the left. And if you see a positive, that means you're approaching a value from the right. This really doesn't come up too much in this first section, but I just at least wanted to introduce you to it because it will come up a lot throughout this chapter. So I'm still going to sprinkle this in throughout this lesson. So the limit as x approaches 1 from the left, or the limit as x approaches 1 from the right, is how we would read those guys. So let me show you a few other guys here. So a couple other cases we're going to run into. So I'm going to show you the graph on page 66. So you're going to see in this case that f of 2 does exist. So I could directly sub in a value, but it doesn't equal the limit as x approaches 2. So let me show you that so you can see what it looks like. So this is page 66. So here's our graph. And so here's what we're seeing. And I'm going off of this information that you're seeing up here at the top. So as you look at f of x, so at 0.20, we do have a value. So 20 does exist. And that's what this is telling you. So when y is 0, x is 2, right? So there's a point on the graph. However, at 1, it does not equal 2, right? And here's kind of the rest of that. So as I just look at my horizontal line that I see right here, so y equals 1 is the line, but they're saying on y equals 1, x does not equal 2, right? So there's a hole in the graph right there. However, when y equals 0, x does equal 2. And so that's the point that you're seeing right here. So in other words, I can have a value where x is 2. It does exist. So there is a value here. However, if you look at the graph, I can see by the graph that my limit is not the same value, right? In this case, you can see that as x approaches 2 from the left, right, my y value is still 1. And as x approaches 2 from the right, my y value is still 1. So my limit as x approaches 2 from both directions is a y value of 1. However, f of 2 is 0. It's not 1. So this is a case where we got to be able to just look at the graph or the functions and answer to however the question is presented to you. So if they just simply said, what is f of 2? So this is not a limit. This is just good old f of 2. Well, f of 2 has a y value of 0. All right, so f of 2 is 0. But if they said, what is the limit as x approaches 2? Well, you can see from the graph, the limit as x approaches 2 of the function is 1. All right, so that's kind of the difference between those two. So at 2, the y value is 0, but the limit as x approaches 2, based on the graph, we are getting closer and closer to a y coordinate, a y value of 1. So that's kind of the two different ideas within that graph right there. So again, it just kind of depends. Are we looking for f of 2 or a limit as x approaches 2? I wanted to show you as far as some limits that do not exist. So here's kind of the next little example within our notes here. So we're going to look at page 67 for these next two guys. All right, so some limits that don't exist. One real popular case is the case where your left and right behavior approach different values. So in this case, and you can tell by the graph, we're looking at this function right here. As x approaches 0 from the left, right, you can see that I'm approaching a y value of -1. But on this side, as I approach 0 from the right, I approach a y value of +1. So my left and right limits are different values, right? And so this would be a case that does not exist. Would be one like this. So that's why sometimes in the future, they may not ask you what is the limit as x approaches 0. Let me write it this way. So if they asked you this, we would have to say it doesn't exist. But if they put a sign on it, like they said, what's the limit as x approaches 0 from the left? Well, now we can answer that one. From the left, our limit would be -1. Right? So that's why these signs will become real important to see what they're asking of you as we look at those guys. We also have sort of the infinity case, which is another non-existent limit for something like this, because infinity is not a value, right? So as you look at this one, as my x approaches 0 from the left, so as I approach 0 from the left, what is my graph approaching? Right? F of x is approaching positive infinity. The same is true on this side as I approach 0 from the right. F of x approaches positive infinity. So even though it approaches positive infinity, so both ends are doing the same thing, but infinity is not a value, right? And so if your graph is approaching infinity, positive or negative, that's still a case where we would have to say the limit does not exist. There are still going to be cases, and you'll see this in calculus next year, where we can still say that my graph is approaching infinity. But really what we have to understand on that is infinity is not the limit. It just describes what the graph is doing. So if we were to say something like, what is the limit as x approaches 0 from the right of f of x? Right. So if we were to say that the limit is infinity, right, that's not really the limit. So sometimes a teacher will accept an answer like this from the left or from the right side, only when you're trying to see that, or what you're trying to describe what your graph is doing. So this would describe what the graph is doing, but again, infinity is not the limit because it's not a value. So let me move on. I want to give you some sort of real examples here that you guys are going to run into for today. So this is in the notes handout, so you're definitely going to want this one. A lot of really good examples on this guy for you guys to see. So let me at least go through some of these. We don't necessarily have to do every single one because right here, starting here and below, it gives you all of the answers and tells you why that's the answer. So use the solution guide here to go through some of these examples. They're really good examples for you guys to see. So let me go through a couple with you though. So do understand the difference between these two questions. So this one is simply asking what is the y-coordinate when x is -4. So if I look at where x is -4, what is my y-coordinate? Right, you can see that I got a hole right there at 2. Right, so in this case, because there's a hole right there, we would say that f of -4 does not exist. Right, there's no y-coordinate right there because there's a hole in the graph for that guy. So let's go over to the next one here. I'm just going to go down the line to give you guys some ideas. So what is the limit as x approaches 4 from the left? Or sorry, as x approaches -4 from the left. So here's my value at -4. So as I approach -4 from the left, you can see that the y-coordinate that I'm approaching is 2. All right, so even though f of -4 doesn't exist, the limit as x approaches -4 does exist. Right, I'm getting closer and closer and closer to a y value of 2. So that would be our limit. Let's go to the next guy. What about as x approaches -4 from the right? So that's a little plus sign on there. So as I approach -4 from the right, again, I am also approaching a value of 2. All right, so our limit on that guy would be 2 as well. So for -4, the limit would be 2, whether it's from the left or from the right. So that's why on this one, let me just jump to this, because these were both the same answer, they were both a y value of 2, that makes the overall limit as x approaches -4 from either side would be 2 on this guy. So if there's no plus or minus here, then again, you're looking from both sides, and they both have to agree with each other in order for this to be your limit. Let's go down the next row of stuff here. So these are all linked together, as you guys will see. So these all had to do with -4. So let's go to the middle row. So what about a value of 1? So you can see on this guy, this one does exist. So it does not exist right here, but it does exist here, right? So where x is 1, we do have a y value of 4. So that can be our solution to this one. So what about as x approaches 1 from the left? So as I look right here, as x approaches 1 from the left, again, I am approaching a y value of 4. So that would be my limit from the left. What about as x approaches 1 from the right? In this case, if I'm approaching 1 from the right side, I'm traveling along this curve because there is nothing beyond it here. So I have to be traveling on this curve. So as I approach 1 from the right side, you can see that I'm approaching a y value of -2. So the limit from the right side does exist. It's at -2. But here's where you run into a no solution case that we were just talking about, or it does not exist because they don't agree with each other. So as I approach 1 from the left, it was 4. As I approach 1 from the right, it was -2. So because they're different, this does not exist. So again, it can only exist in a case like this, it can only exist if you're coming from a specific direction, but not from both directions. One more real quick. So f of 6, you can see that f of 6 does exist. It has a y value of 2. What about as we approach 6 from the left? So as I approach 6 from the left, you can see I am approaching a y value of 5. So that would be for this guy right here. As you approach 6 from the right, I am also approaching a y value of 5. So he would also be 5. So if you look at this one, what would the last one have to be? Well, as x approaches 6, since it was 5 from the left and 5 from the right, we could say that the limit as x approaches 6 in general is 5 as our limit. And so that would be the last one. So this will be a great one for you guys to hang on to. So good luck with the first section. Again, you have worked out solutions online that should help you and be a good guide. I will try to answer questions as best as I can through email, but that's why I'm trying to provide you as many tools for you guys to sort of answer as many of your own questions as possible. So you do have access to Slater for this. I put it on the website under Worked Out Book Solutions. I also have the handwritten Worked Out Solutions on there for you as well. So hopefully that will help you answer questions, but beyond that, please check those first, and then if you still are having an issue, let me know and I'll try to help you out through email as best as I can. So until next time.